Welcome to the channel. In this video, we're going to be looking at simple ionic nomenclature, going from the formula to the name, and from the name to the formula. In the previous video, we looked at the structures and properties of ionic substances, looking at cations and anions, how ionic substances come to be, and some really important properties in this overall structure of ionic compounds. So feel free to check that out. But for now, let's get into naming these guys. Awesome. So we're going to go from the formula to the name first. And this process is somewhat easier. And it has this very simple outline kind of formula thing. First, you want to get the element name of the cation. Write that out. Then, you want to get the element name of the anion minus the last few letters, typically 3. And then instead of those last three letters, you want to add the IDE ending, right? Just literally write IDE. Alright, so the cation is typically the metal, it's the ion with a positive charge. The anion is going to be typically the ion with a negative charge, and the IDE ending is just the suffix you add at the end. Alright, awesome. Here's an example, NaCl. Let's name it. Let's go from the formula to the name, and we can use this three-step formula here. So let's write out the cation element name. In this instance, the cation, which is the metal, which is sodium, is Na, so it's going to be sodium. Just write out sodium, the entire name. Right? And then the anion element name, which is going to be the part over here, the non-metal, which is going to be chlorine. So we have to write chlorine out and then add an IDE ending. So sodium, chlor. Now it's typically chlorine, but since it's an ionic compound, we have to add this IDE ending. So chloride. And that's it. That is how you name an ionic compound from this formula. Now, it's really important to note that it is not like covalent substances. You do not need to add any prefixes. Now, we did a video on covalent substances already, and as you can recall, there were a lot of prefixes from like 1 to 10. Do not worry about that for ionic compounds. Okay, when it comes to ionic compounds, the subscripts are not important. There are no prefixes. However, if you would like to watch a covalent video, we'll put that link in the description. But for now, let's work on some practice problems. All right, so these are 3 examples that I got over here. Take time, pause the video, and then try to see if you can solve these questions. You just have to use this very simple outline over here, and hopefully you can get it. I'll be going over it right now, so pause the video. Alright, so I'm going to take the time to go over each of these examples. And first, we have Na2O. Alright, so that is a chemical formula name for it. And the only thing you need to be able to do really is identify it from the chemical name, and that the formula name. And that just comes with practice, so just look in the periodic table, just understanding these elements. So Na is associated with sodium. So we have sodium again, as you saw over there. Sodium. And then here you have an oxygen. O stands for oxygen. So you want to do the same thing. You want to write oxygen, but instead of oxygen, you want to remove the last 2 letters and add an IDE. So that becomes oxide. Oxide. So it's not oxygenide, it's oxide. All right. So you want to remove the last 2 letters and add an IDE suffix. And the name of the compound is sodium oxide. Just like that. All right. Next one. Let's do this one. This one, it looks a bit more scary just from the numbers, but very straightforward. You see Ca, that's calcium. So just write it normally, calcium. Nice and easy. So that's the cation element name. And then you want to write the anion element name. The P stands for phosphorus, but remember you have to have an IDE ending. It's not phosphoride, it's going to be phosphide. And then you have the IDE ending, right? So oxide, phosphide. Awesome. Finally, we have KBr. We're going to turn that into the K stands for potassium. So it's going to write potassium out in its entirety. And then you have Br, which is going to stand for bromide. Sorry, the Br is going to stand for bromine. You add the IDE ending, so it's going to be bromide. All right, now let's go from the name to the chemical formula. Kind of the opposite of what we did earlier. The example problem is going to be calcium chloride. And the first thing I did is that I wrote the chemical representation of calcium and chloride. So calcium over here, Ca, and chloride over here, Cl. Chlorine over here, Cl. And the first thing you want to do is you want to get the charges on the ions because you have to remember that ionic compounds are between ions of the elements. Now, a quick and easy way to do this is that if you look at the periodic table, there are trends between groups and ion charge. For example, the first group can have a 1+ charge. All the ions in this group are going to have a 1+ charge. Second group, all the ions in the compound are going to have a 2+ charge. In the 13th group, all the ions are going to have a 3+ charge. In the 15th group, you're going to have a 3- charge. 16th, 2-, 17th, 1-. If you just remember these numbers and this relationship, it becomes very easy. It corresponds with the valence shell numbers that each group has. So that's where that comes from. And if you just understand this, it'd be really easy to determine these ionic charges really quickly. If you want to take a longer approach, and if you really wanted to double down and make sure and understand what you're doing, you can look at the Bohr-Rutherford diagrams. So here you have calcium and chlorine's Bohr-Rutherford diagrams. And what you can do here is you can look at what it takes for them to become ions. And I've already circled these. Calcium has 2 valence electrons, so the quickest way it could achieve the octet, have a full outermost valence shell, is to lose these 2 electrons. So they're just going to get out of here. All right, so now calcium is going to have 2 less, so it's going to have 2 more protons than electrons because originally you had equal amounts. You lose 2 electrons, now you have 2 more protons. So you're going to have a 2+ charge. All right, so that is how C2+, you see calcium over here, 2+ charge. That kind of explains these trends here. And then here for chlorine, it has 7 valence electrons, 1, 2, 4, 6, 7. So the easiest way for it to achieve the octet is to gain an electron. So an electron is going to pull up here. Chlorine now has a full shell, but now you have 1 more electron than proton because before you had a balance, now you add an electron, so it's going to have a net negative charge. All right, look at the periodic table. Chlorine has 1- charge. See, so that kind of proves these trends over here. This is really just based off the valence shell configuration. All right. So using these trends, using the Bohr-Rutherford diagrams, whatever it is, you can determine the ionic charge. And as we did here, I'm going to fill that in. So you have calcium is going to have a 2+ charge when it's an ion, and chlorine is going to have a 1- charge when it's an ion. All right. So from here, some people like to use a crisscross method. Personally, I do not like to use this method because, you know, when I was learning this, it was just really confusing to me. I didn't know what to crisscross, why I was crisscrossing, and it felt like just memorizing some technique, and I had no idea what I was doing. The way that I think about it is trying to combine these compounds in a way that you have a neutral overall compound, kind of like a game. So say I'm going to write this out again. So you know that 2+ charge here. So let's write it out again. So we have CaCl2, CaCl. And what's important to note here is that the overall compound has to be neutral. That's what ionic substances are. Otherwise, it would have a net charge. It would be an ion. This overall substance is going to be neutral. Now, you know the ionic charges here, that it's going to be 2+. So you know that the second compound needs to have an overall 2- charge to balance it out and join to make a compound. So how would you do that? This means that you would need 2 negative charges to balance out the 2+ positive charge. So you'd write a 2 on the chlorine. And that is it. That is the chemical representation of calcium chloride, CaCl2. So just to clarify, what I did here is that I identified the ion charge, and then from there, I kind of thought of it in a way that would allow me to have a net neutral charge on the overall compound, how I could combine these ions together. All right, so let's look at some practice problems. So I'm going to pause. You can go ahead and pause the video. Work on this on yourself if you think you can do it. If not, I'll go through them myself. So give it a chance. All right. So magnesium nitrite. Okay. So the first thing you're going to do is write out magnesium, and then nitride corresponds with nitrogen. Take out the IDE. Nitrogen. All right. So magnesium is going to have a 2+ charge. We can see that in our trend over here. And if you just look at its valence shell configuration, nitrogen, 3- charge. All right, so this one's going to be a bit more difficult because we're going to have to adjust the numbers on both elements because 2 and 3, they're not going to cancel each other out just if you keep multiplying them, it's not going to cancel each other out. We have to find the least common multiple, which is going to be 6. All right, that's how you know you can cancel. Like if you have 6 positive charges and 6 negative charges, they'll cancel out. So how do you do that? You can multiply this by 3. So you can have 3 magnesiums. So now you have a overall 6 plus charge on the ions. And how many nitrogens would you need to cancel that 6 plus charge? You would need 2 because the nitrogen is 3 minus. So you're going to have Mg and Mg3 and 2. All right. So what I did, identified the charges, and then I combined them in a way that the overall net charges cancel out and equals 0. Let's do potassium iodide. So you have potassium, which is K, and you have iodide, which is I. Potassium, as you can see over here, has a 1 plus charge, 1 plus net charge, so it's going to be a plus. Iodide has a net negative charge, negative, and this already cancels itself out, so that's pretty much done. So the overall formula is KF. Alright, so now let's do barium fluoride. Alright, this is going to be the last one here. And barium, if you look on the periodic table, barium's down here. Alright, and it has a 2 plus charge. So you have barium, B, A, and it's going to be a 2 plus charge. And then fluorine, its ion is going to have a 1 minus charge. So F1 minus. Alright, so in what way can we combine these elements so that the overall charge is 0? Right, so you have 2 plus and you have a 1 minus. You need a 2 minus for the 2 plus and the negative charges to cancel out, for the positive and negative charges to cancel out. So if you get 2 fluorines, it's going to balance out with the barium's 2 plus. So what you're going to do is BaF2. Alright, so hopefully that made sense. It's an alternative to the crisscross method. There are 1,000 videos if you want to learn the crisscross method. I suggest you do it this way because this way, it's very hard to mix up. You know what you're doing, and you get an intuitive understanding of what you're doing. Alright, so in this video, we looked at ionic compounds, going from the formula to the name and going from the name to the formula. Hopefully you enjoyed the video. If you did, click the like button, consider subscribing to the channel, and I hope to see you guys next time.